All right, in these notes we're going to talk about what organic compounds are, and we're going to give some examples of organic compounds and see how they're named and how they're worked. So let's take a look. All right, so we have this word organic thrown out everywhere, it seems, these days, in from organic foods to organic cleaning products and stuff like that. So what does organic actually mean? Well, in the purest sense, organic is just compounds that contain carbon in them. Okay, that's all organic actually means. With a couple of exceptions. We're going to exclude carbon dioxide as an organic compound, and we're going to exclude anything with a carbonate ion as an organic compound as well. So these are two exceptions to that rule, but everything else that is based on carbon being in the molecule is called an organic compound. Now, when we talk about organic foods and stuff like that, obviously food is organic. It's going to be made up of carbon, but what it means in that kind of sense is that it's food that is not, grown with inorganic compounds, which are chemicals, basically, which are, from the ionic salts and other kind of stuff. So that's what it means in the food sense, is that it's not, made with pesticides or anything like that. But organic in the pure chemical sense is just compounds with carbon in them. All right, our next question is, what are hydrocarbons? Hydrocarbons are a type of organic compound, and in their name kind of tells you what they are. Hydro means there's hydrogens, and carbon means there's carbons. So basically, hydrocarbons are very simple organic compounds that only contain carbon and hydrogen. So the simplest hydrocarbon is a molecule called methane. It's got one C, and because the C's have to, all carbon has to make 4 bonds according to our honk rule, it's going to be CH4, right? So that's the very, very simplest. Now, there are other hydrocarbons that are very long chains of carbons and hydrogens. So here's an example of one of those. Okay, here we have a chain of carbons all strung together with their hydrogens around it. So this is butane, which is C4H10. Okay, and then still other kinds of hydrocarbons are branched chains. So they have a long chain, and then they've got, kind of branches coming off of it. So let me show you an example of that one. So here we've got a whole huge chain of carbons, right? And then we also got this little branch here that's coming off of carbons. And so this is C7H16, I believe. That's what we call heptane, okay? Because remember, hepta is for 7, so it's heptane. All right, so let's take a look at specific kinds of hydrocarbons. We're going to start with something called alkanes. All right, alkanes are a particular type of hydrocarbon that only have single bonds. So all the H's and the C's are all single bonded to each other. There's no double bonds or triple bonds found in the molecules. So we're going to take a look at 3 different types of alkanes. The first one is our straight chain alkanes, which is going to be kind of all in a straight line, like it basically describes in its name. So the first one actually isn't a chain because there's only one carbon molecule, but methane is the first one, CH4, okay, is methane. Now you're going to need to know the names and the formulas for these things so that you can be able to, to do this on the test. And we're going to have an activity tomorrow where you guys are going to, look at things and name them, or if I give you the name, can you, draw out the structure. So make sure that you know the names associated with these eventually. So methane is CH4, okay? Ethane is 2 carbons. So they kind of go in order from increasing number of carbons. So if this is 1 carbon, ethane has 2 carbons, propane has 3, butane has 4, and then it keeps on going. I'm just going to require you to do 1 through 4. So ethane is C2, okay, H6. All right. Another way we can kind of look at it is, this is kind of an expanded way. CH3CH3 is another way we can actually write ethane in it. And I've discussed this a little bit before, but this is like an expanded version of the molecular formula that actually tells you, what the carbons are going to have around it. So the carbons will always be attached to each other, and the first carbon here has 3 H's around it, and the second carbon also has 3 H's around it. So it kind of gives you an idea of the structure within the formula. All right, so that is ethane, which is a 2-carbon chain. Now if we go to a 3-carbon chain, then that is propane. So propane is C3H8. Okay, so again, if we do the expanded, we'll have the first carbon with 3 hydrogens on it. The middle carbon will only have 2 hydrogens, since the other 2 are being connected with the other carbons. And then the last carbon will have 3 H's around it as well. Okay, so this is another way to kind of show the expanded molecular formula. All right, and then our last one that I'm going to have you guys know is called butane, and butane is C4H10. Okay, so it's a chain of 4 carbon atoms together, and it's saturated in a sense with hydrogen, so that's all connected to hydrogen. So here again, we're going to have the first carbon with 3 hydrogens on it. The second carbon has 2 hydrogens. The third carbon also has 2 hydrogens, and the fourth carbon will have 3 hydrogens. All right, so that's our straight chain alkanes. Now we also have branched chain alkanes. Remember, which is like it's chain with some branches kind of sticking off. So the only example that I want you guys to know is isobutane. So we're going to have 3 carbons, and that fourth carbon is going to be kind of in the middle. So we've got a thing like this. Okay, so with all the H's. So regular butane is C4H10, and this is isobutane, still C4H10, except we've put one of these carbons on the middle carbon as a little branch here. Okay, so this is kind of branching instead of in a straight chain. So that's what we call isobutane. Now, the last type of molecule that we can have with these alkanes is what's called a cyclohexane. Okay, so a cyclohexane, cyclo kind of means circle, or a cycle that goes around in a circle. So in cyclohexanes, the carbons form a ring. Okay, so in cyclohexane we have, hexa means 6, remember, so we're going to have 6 carbons making a ring, and we're going to have all H's attached to all of them. So this is what it looks like. All right, so that's what cyclohexane looks like. It's a little sloppy, but you can see that in this one we've got a ring of carbons, and then all the hydrogens that make up their honk 1, 2, 3, 4 rule. All right, so those are some different kinds of alkanes, and the last 2 things that I just want to kind of go over with you about alkanes is that anytime you have a name of an alkane, just a bunch of carbons and hydrogens together, it's always going to end with ANE. Okay, just like alkane ends with ANE. All right, so that ANE is going to kind of signal that you're going to have just single bonds in the molecule. Okay, so that's one of the features. Now the other feature is that alkanes are what we call saturated with hydrogens, meaning that every possible bond place has a hydrogen in it. Okay, so none of the carbons are attached to each other, and it's nothing but hydrogens, and there's no double bonds, no triple bonds. It's totally saturated with as many hydrogens that can fit in the molecule. Okay, and that's kind of important because we'll see that the next one that we're going to talk about is alkenes, and those are unsaturated. All right, and that actually has to do with the fats that you find in your food. Saturated fat is, again, saturated with a whole bunch of hydrogens. So within the fat molecule, it's all single bonds. Okay, but unsaturated fats have double bonds. And so, there's not as many hydrogens in an unsaturated fat. That actually makes it a little healthier for your body versus the saturated fats. But anyways, that's just a little food connection here. But we're going to go on to the fourth question. What are alkenes? All right, so another type of hydrocarbon is called an alkene. And again, like I said earlier, these are unsaturated hydrocarbons, meaning that we don't have, the maximum amount of hydrogens available, but because we have double bonds in the molecule. All right, so alkenes are going to have double bonds. Now, we're going to go through some examples of names and structures of these. So the first one we're going to start with is ethene. And if you remember from ethane, ethane has 2 carbons, and so ethene also has 2 carbons. That, eth kind of name or prefix to it is means basically 2 carbons. So in ethene, we're going to have 2 carbons and 4 hydrogens. So when we do that, we're going to have our 2 carbons and our 1, 2, 3, 4 hydrogens. So that means that we got to have a double bond in between them. And so that double bond makes it ethene instead of ethane. All right, if we add another carbon, again, it's prop. All right, just like propane has 3 carbons, propene also has 3 carbons. So this guy is C3H6. All right, so if we draw him out, we got 3 C's and we got 6 H's. 1, 2, 3, 4. Let's see. 5, 6. And so, you see that these first 2 carbons are missing a bond, and then so we know there's got to be a double bond there. So that's propene. All right, now when we get down to 4 carbons in a chain, we actually have 2 different options. We have 1 butene and 2 butene. And remember, just like butane, the but means 4 carbons. So in 1 butene, okay, it's 4 carbons and 8 hydrogens, and the 1 here means that the double bond is after the first carbon. So it looks like this. Okay, so we see here that this double bond is right by that first carbon. That's why it's called 1 butene, because the double bond's at the 1 position. Now, 2 butene means that the double bond comes after the second carbon. So 2 butene looks like this. Okay, just like 1 butene, its formula is C4H8, and that 2 that we see is representative of the double bond being after that second carbon. All right, last but not least for this question is the fact that anytime you see names for these kind of hydrocarbons, okay, these ethenes, it's always going to end in ENE, okay, just like all of the, if you take a look, they all end in ENE, just like alkenes ends in ENE. So that's, kind of a precursor of how we know that there's going to be a double bond in it. The ENE means that there's going to be a double bond. All right, we're going to take a look at our last question, which, if we talked about single, double, now we're going to get to triple bonded hydrocarbons. All right, our last type of hydrocarbon we're going to talk about is one called alkynes. Okay, so again, these guys are unsaturated hydrocarbons, meaning that they don't have all the hydrogens possible, because there are triple bonds in these ones. So we can see that the name, I'm just jump down to the bottom, the name always ends in YNE for alkynes, just like alkyne ends in YNE,
And that means that we're going to have triple bonds. So that name, if you see the name out end in YNE, it signals to you that your structure should have a triple bond in it. It's an alkyne. All right, so let's take a look at some examples. All right, now our first example is ethyne. Remember, eth means two carbons, so we're gonna have two carbons together. So we're gonna have C2H2 is ethyne. So we have two C's, right, and two H's, one on each of the C's. So that only leaves, there's only one bond with the C, so we need to have three more. We need to have that triple bond to make it follow the honk 1, 2, 3, 4 rule. So ethyne is C2H2. Now, going down our list, adding another carbon to it means that we've got a prop group. And so prop means 3, so we have C3. And then here, it's going to be H4. Okay, so we've got three C's in a row. One of them is going to be double bonded, okay, to the other. So we've got an H here. And then we've got another bond here, so that center carbon has 4 bonds, and now we've got, that last carbon, we need to add 3 H's to it to make C3H4. All right, and then still going down the list, we've got adding another carbon to our chain, we get a bute group, okay, right? So bute means 4, so 1 butine is C4H6, okay? And again, the 1 means that the triple bond is found after the first carbon. So we're going to have a carbon, a triple bond, carbon, carbon, carbon. And then we fill in the rest with our hydrogens. Okay, so 3, 4, 5. Oop, this should be C4H5. My apologies. Right? 1, 2, 3, 4, 5. Yeah, 1, 2, 3. Oh, 6. Nope, I was right. 6. All right, so C4H6. All right, is butine. All right, and then our very, very last one is 2-butine. Okay, so again, we're going to have C4H6, but now this triple bond is going to be after the second carbon. So we're going to have a carbon, triple bond, carbon, carbon. All right, and we'll fill in with our H's. 1, 2, 3. That's got 4, that's got 4. Okay, 4, 5, 6. All right, so that's 2-butine. All right, so when you're going through, these notes in the activity tomorrow, you're going to have to flip back and forth, to match up the structures or the molecular formulas with the proper names. And so a really good way to study these, to get them in your head, is to write them out, okay, and perhaps also make flashcards as well. The more you can write them out and visualize them, the better you'll learn the names. All right, we'll see you tomorrow for our activity.